Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this Techstrong learning experience brought to you by AWS and PagerDuty. My name is Cody, and I'm the host of Techstrong Learning, and we have an exciting program ahead. Before we get this kicked off, we do have just a couple of housekeeping notes I'd like to review. First, today's session is being recorded. So if you miss any of our discussion, perhaps you'd like to rewatch or maybe share with a friend. The on-demand recording will be made available shortly after we conclude this live session today. If you'd like to engage with us, there are a couple of options for you to do so. The first of which is the chat tab, which can be found on the right side of your screen. Go ahead and start testing that function out for us right now by letting us know from where you're joining us. Directly to the right of that chat tab, you'll see it says Q&A. For any questions you might have for Jeremiah, we want you to send those questions into that Q&A section. Just helps us keep track of them better, and we do want to address as many as we can today. Additionally, if you click on the Handouts tab, you will see there are some resources available for you, so feel free to grab those. And of course, before we close out, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of our program. Our topic today is automated diagnostics for EKS and Fargate. And I'm joined by Jeremiah Lodis, Senior Solutions Consultant at PagerDuty. So Jeremiah, thank you so much for joining me today. You want to go ahead and get this started?
Excellent. Well, thank you for joining, everybody. My name is Jeremiah Lodis. I'm presenting from San Diego. So good morning and welcome to Automated Diagnostics for EKS and Fargate. Today, we'll be discussing how to debug faster by capturing crash states on AWS Fargate and Amazon EKS. For the purpose of our demonstration, we'll focus within Fargate. However, the solution we'll be discussing is applicable for both orchestration methods. And we'll be following this webinar up with another one that's a little more Kubernetes focused next month. So, like I said, my name is Jeremiah Lodis. I'm a senior solution consultant here at PagerDuty. I primarily work with organizations looking to optimize their operational resilience and utilize best practice in automated incident response, AIOps, process automation, and customer service operations. Each of these is a core tenet of the PagerDuty Operations Cloud, which is the technology we'll be using to solve this widespread challenge experienced by teams utilizing EKS and ECS orchestration methods for their infrastructure. It's important to note, the solution we've developed for debug state capture was built because we observed a large number of organizations who were considering moving to ECS or who had moved part of their infrastructure to ECS already. And as such, there's a great need for the ability to easily capture this debug state data without really an easy way to do so today. So let's take a quick look at the technology we'll be using in PagerDuty to solve this problem. The Operations Cloud is PagerDuty's platform for modern operations. We solve unplanned, unstructured, time-sensitive, and high-impact work. It detects and analyzes event data from across your digital operations or monitoring and observability stacks and automates infrastructure and workflows. Then it's going to mobilize the right team members to minimize the impact of disruptive events on your customers, your employees, and your brand reputation. PagerDuty Operations Cloud integrates with hundreds of points across your ecosystem, such as your EKS and ECS infrastructure. And it learns constantly from over a decade of data and orchestrates resolutions that keep thousands of companies, from Zoom to American Eagle to some of the world's largest banks and financial institutions, operating in a world of constant disruption. The PagerDuty Operations Cloud simplifies operational work, improves operational resilience, and increases the capacity of your teams. It has 4 main capabilities: AIOps, automated incident response, process automation, and customer service operations. It's an end-to-end platform to automate the detection, diagnosis, and taking action on disruptive events so that customers and teams experience less disruption. We'll be using the PagerDuty Operations Cloud solution to demonstrate how to easily manage and automate the resolution of triage and resolution of customer impacting incidents in our EKS and ECS environments. Let's quickly take a look at the technology on the AWS side now. Both Amazon EKS and AWS Fargate offer managed solutions for container orchestration, providing ease of use, scalability, security, and very importantly, integration with the AWS ecosystem. EKS is well suited for organizations that require fine-grained control over their Kubernetes clusters. ECS provides more control and flexibility over the underlying infrastructure, makes it suitable for organizations with specific infrastructure requirements. And additionally, Fargate offers a simplified serverless experience, abstracting away the infrastructure management and allows users to focus on running containers without the need for EC2 instances. The advantages of running our infrastructure thin are well documented. However, it often leaves operational teams with very little options when trying to send commands to containers in Fargate or ECS, for example. With many organizations actively moving away from the ability to directly connect to containers, this is by design primarily. However, there are scenarios where having access to the containers command line becomes crucial, particularly in scenarios such as debugging and state capture. To overcome this challenge, PagerDuty has developed a powerful plugin that enables command execution within Fargate and ECS containers, regardless of whether they're ECS-backed or serverless. We'll cover this in more detail during our demo, but before that, let's tee up the problem a little bit more here and talk about how these challenges come about in day-to-day operations. The separation of duties between dev and prod means that teams can work together easily to manage large, complex environments without overwhelming either side of the fence pictured here. However, it can create challenges when we work through disruptions that impact our production environments. The separation of duties really frequently means developers don't have access to production environments. And this can be a problem with ephemeral environments such as containers and the cloud. So to walk through a common scenario, when incidents occur, responders feel the pressure to restore that service as quickly as possible. And as such, it's fairly common for responders to apply a short-term or band-aid fix. This restores a service fairly quickly so that the impact to the customer experience is minimized. Unfortunately, though, this can still result in a poor customer experience because the issue will more than likely happen again. Not to mention that it results in a poor operator experience because they probably end up having to deal with the same issue again. So in order to restore both service availability as quickly as possible, while also trying to protect themselves against future occurrences of the issue, the responder will apply the Band-Aid fix, and then they will create a bug ticket or tech debt ticket for the associated development team. And while this is fairly standard practice, what this means is that developers are frequently left asking for information from those that open the ticket, or they end up spending a lot of their own time gathering data on what was going on in the environment and in the application at the time of the issue. This inherently means that a lot of time is spent on tech debt and not on new feature work. But with PagerDuty Process Automation or Runbook Automation, we're able to give responders and developers the best of both worlds. Now, when the issue occurs, PagerDuty Process Automation captures application state. This could be a Java heap dump, for example, and then it persists that information in storage. This can be kicked off by the click of a button, or it could be driven by the event themselves through PagerDuty's AI ops. As soon as the data has been captured, the Band-Aid fix can be automatically applied. And then lastly, PagerDuty will append a link to where the debug data is stored in the ticket that is then passed to the developers. This process not only cuts down on time to restore the services, but also reduces the time spent on bug fixes and tech debt tickets, and ultimately ends up greatly reducing toil for both sides of the fence when critical operations are on the line. So I'm sure we're probably ready to move on from the slides. So let's dive into the demo here and take a look at how this actually works. So here we're in PagerDuty, and we can see I just received a page about an unhealthy service in AWS Fargate. Recognizing this is related to a mission critical service, my initial response is to resolve it as quickly as possible. And I could do this using a rollback, a restart, adjusting the resource limits for CPU and memory on the container. And with PagerDuty Runbook automation, you can see I have these types of Band-Aid fix actions pre-configured to be easily run from the incident in PagerDuty. However, event orchestrations in PagerDuty can allow for either responder or event-driven invocation of these types of runbooks through our advanced rules engines. In addition, these automated runbooks can be executed from your ITSM ticketing tool of choice. They can be run from the PagerDuty mobile app. They can be run from the PagerDuty Slack integration. So you can see we've got a lot of options for folks like yourselves to execute these types of automations wherever you're working. If we look back at the actions here, however, we can see there's another option to collect the debug information as a thread dump in the Fargate container. Once we click this debug state capture option, automation actions in PagerDuty is going to execute a job in PagerDuty Runbook Automation, our SaaS platform for automated runbooks. This is going to then communicate with the production AWS environment through a secure API gateway and execute the necessary commands using an SSM agent. So let's run this job and take a look at what happens in PagerDuty Runbook Automation. So if we jump over here, we can see the execution of these job steps. So here we can see that it's performed a TCP dump from within the container in our production task. Step one of this job right here, this is just going to be gathering the process ID of the app inside of the container. Then it's going to pass that information into step two. And this is where it performs the actual thread dump. But in this case, we're intentionally not logging the thread dump here in the job. We're saving the thread dump in memory so that in this step, we can pass it through a Lambda function to our S3 bucket, which is then performed in step three, where we send the actual JStack output to S3. Then if we go to step four here, we can see that the link to the persisted data will be passed as a note on the PagerDuty incident, which will then be sent to any of our connected PagerDuty tickets or chat ops tools such as Slack or MS Teams. If we go over to Slack right here, we can see the thread dump is available to anybody else who's involved in this event. But the important thing is it's going to be saved for later use by responders involved in the bug fix process. So to accomplish this, Runbook Automation is going to collect the debug data from Fargate by executing debug commands on the original existing container itself. If we were to do this in EKS, for example, though, we could execute the debug commands in a new ephemeral container that we would then attach to the existing pod to get the debug information that would then be passed on to storage so that we could use it later on. But here we can see, like I said, in the final, in step three, that the debug data is sent to persistent storage. In this case, we're using S3, so we can use it later in the bug fix process. But we can see here in PagerDuty that it's been added as a note on the incident, and it's been collected as well on the PagerDuty incident timeline. So this is really just indicating the availability of this debug data in our internal S3 bucket, which was also executed by RBA. So with this captured and persisted data, I can confidently implement a remedial action. And then later on, after a ticket is identified, is created to identify the root cause of this issue at the code level, developers can use this debug data to expedite the resolution process. It's important to note, though, that the ability to execute debug state capture, as well as any remediation action, can all be driven from the event payload rather than manually by a responder. So we can see that I've got rules here to execute some of these automations based on the payload of the alerts flowing into PagerDuty. And by using the payload, we can use PagerDuty's rules engine to execute these playbooks in Runbook Automation automatically. Ultimately, this is going to reduce the number of pages and interrupt work our on-call teams need to manage, while simultaneously radically driving down response and resolution times related to our mission critical applications. And lastly, by using the debug state capture method developed by PagerDuty, we have an effective mitigation strategy for one of the primary challenges to running our infrastructure thinly, as we're able to easily capture the debug data required to reduce the work involved in the bug fix process, which means with PagerDuty Runbook automation in conjunction with EKS, ECS, or Fargate, we can have our cake and eat it too. And as I mentioned, we can leverage event orchestration to trigger it automatically rather than manually, as I've shown here in the demo. And this is just going to reduce the number of times on-call personnel are awakened or notified by PagerDuty, and decreases the time to resolve these tickets. And consequently, folks like yourselves can focus on more high-value tasks. So rather than firefighting, we can reduce toil and burnout for on-call folks and allow us to drive aggressively at SLAs and delivering an excellent customer experience. Now, there's one more component to this, right? So let's imagine an organization that has Band-Aid fix automation pre-configured, maybe like we do here, right? What we typically see in these cases is a large number of transitory issues that pop up and resolve before human intervention is required. While in these cases, the service is quickly restored, it's possible that there's an issue being experienced by the customer without our knowledge. As well, it makes it even more difficult to understand how to prevent these types of issues from happening in the future. If they're resolved so quickly, the information about the state of the application during the disruption isn't recorded by the responder. However, with PagerDuty's debug state capture, we can use the payload of an alert to automatically trigger the debug state capture automation at the time of disruption and then record it in a Jira ticket, right? And this means that PagerDuty, this means that we're able to capture the state automatically multiple times over the course of perhaps a longer period of time, because the issue is transitory and recurring. So for those of you who are familiar with things like status flaps on network devices or spikes in CPU or memory usage, these are things you probably already have auto remediation around, or they might just be naturally occurring transitory issues. And each time they occur, PagerDuty can automatically capture this debug state. And we'll be able to capture this state over these multiple occurrences over a longer period of time. And so what can happen is when a dev has the bandwidth to pick up this ticket, they can look at debug data from each of these occurrences and identify if there's a pattern. This is a slightly nuanced extension of the use case that we previously discussed, in that not only does the debug data give us information for issues that pop up from time to time naturally in the course of operations, but this can also be an incredibly powerful vehicle for longer-term trend analysis in giving developers access to data that would previously take exorbitant amount of time and grief to extract, if it's even available at all. And this allows us to greatly optimize the time of our devs by reducing a major point of friction and toil, and enable them to get to solutions faster and free them up for higher value development work, as I mentioned before. So let's jump back to the slides. And what I'll say is I'm just going to kind of walk through some of the architecture here in a little bit more detail, but feel free to start dropping questions into the Q&A if there's anything that comes to mind. But I just want to walk through some of the architecture steps here one more time so you get have a very clear understanding of what's going on. Up here, we can see our PagerDuty environment, as well as here, our PagerDuty Runbook automation environment. So the first step here is we're going to kick off the automation. And like I said, this is either a responder or event-driven invocation of the runbook from a PagerDuty incident. That is coming from observability or monitoring data that's looking at your EKS, ECS, or Fargate environments, and monitoring the health of those critical applications or services or tasks that are running there. In step 2, we can see runbook automation is then going to communicate with your AWS environment through a secure API gateway, and it's going to execute the necessary commands using an SSM agent. The SSM agent is going to capture the application state, such as a heap dump from the container. Then the debug data is sent to persistent storage. In this example, we used S3, but this, of course, could be sent back to PagerDuty and stored in a different way if that's your preference. Then step 5, we can have RBA, also runbook automation, also apply the short-term fix after the debug data has been collected. And then in step 6, that link is going to be sent to the PagerDuty incident, where it is going to be linked with an associated Jira ticket, the Slack channel, the postmortem in PagerDuty, or any other associated ITSM tickets that are linked to your PagerDuty incident. So just kind of looking at this one more time as a solution between the PagerDuty Operations Cloud and your AWS environment. Ultimately, PagerDuty is taking in an enormous collection of real-time data from your systems on the AI ops side here, right? And that's going to include signals directly from your EKS or ECS environments, or customers who may have already contacted your customer support, right? And with AI ops, we're going to use machine learning to group, suppress, and deduplicate, and ultimately reduce noise to on-call responders and reduce burnout and notification fatigue. And it's going to allow them to focus on what's most important. And in fact, customers who've enabled this part of the platform see about half of the incident volume of other users of PagerDuty. And from there, we automate the diagnostics and remediation steps. That could be the debug state capture. That could be gathering other diagnostic information from tooling, and then executing those remediation steps with runbook automation. And this could happen before humans even woken up. And we know that humans assisted by automation and AI is far better than AI alone, which is why the human mobilization component of our platform remains so relevant. Here we can make sure the right responders are engaged, stakeholders are informed, and responders are armed with the actions they need to keep downtime to an absolute minimum, and especially when every second counts. So let's kind of focusing here. PagerDuty has plugins and integrations for the automated diagnostics that you need in all of your AWS tooling. As well, we have common components that can be run in an AWS environment. As well, we have logging and management of AWS environments, and important add-ons to your AWS environment. So PagerDuty Operations Cloud can interact with all of this and make sure that we're executing automation that's critical for your teams to have available to them at the touch of a button or invoked automatically. That being said, I'd like to kind of jump over to the Q&A and see if there's any questions. Just feel free to drop them into the chat or drop them into the Q&A. I know I might have gone a little bit fast there, so we've got plenty of time to tackle any of your questions. So let's see here. I don't see anything in the chat or the Q&A, so I'll leave a couple moments here for us to see if there's any questions that pop up. But once again, just opening it up. If there's any questions about anything that we showed here, the debug state capture solution, how it integrates with PagerDuty runbook automation, AWS, ECS or EKS, feel free to drop it into the chat. Hopefully there's no questions because everything was very clearly explained. We'll kind of leave the chat and the Q&A open for a little bit longer. Just double checking and making sure. Okay, well, if there's no questions, to learn more about runbook automation and incident diagnostics, We have a blog that you can check out here. The slides will appear in the handouts. We have some more information about what are automated diagnostics. Automated diagnostics can go well beyond your ECS and EKS environments to gathering information that's essential for your incident response process. We have some more information about incident forensics, and then some more Kubernetes and ephemeral container specific information. And then, of course, if you'd like a custom demo or anything like that, feel free to contact us at PagerDuty/contact us, and we'll get back to you as soon as possible. So I know we're finishing up a little bit early here, but I hope this session was useful for everyone who attended. Once again, my name is Jeremiah Lodis. That's jlodis at pagerduty.com. Feel free to reach out on LinkedIn or through my email if you have any questions or you'd like to talk a little bit more in detail about anything that you saw today. And with that being said, I will stop sharing and thank you all for your attendance. And I hope you all have a wonderful day.
Awesome. Jeremiah, thank you so much for that. It looks like we're not receiving any questions, but we have received a couple of thank yous. So excellent job today. And thank you so much for joining us here on Techstrong Learning. So I would like to remind our audience that today's session was recorded. So should you want to rewatch, you will be receiving an email with a link to access this recording on demand. You can also find it living on the DevOps website at devops.com/webinars, and then just be sure to look in the on-demand section where it will be there waiting for you. The 4 winners of our $25 Amazon gift card drawing are Chanel I, Kirk M, Nicholas R, and Jozo C. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. You should be receiving that email in about the next 48 hours, but if you don't happen to see that, check your spam folder just in case it gets filtered out. I'd like to thank AWS and PagerDuty for sponsoring our program today. And to our audience, thank you so much for joining us. We are going to let you have the next 30 minutes of your time back. So hooray for a shorter webinar today. But we do really appreciate you spending time with us today. And we would just like to ask you to fill out a quick survey that will pop up. As soon as we close out, it will pop up on your screen. Let us know what you liked about the shortened format, or if you have any recommendations for an upcoming program, we would love to hear your thoughts. So Jeremiah, thank you so much for your help. Jake, I appreciate you stepping in with us as well today. And everyone, you may now disconnect.